A fleet of robotic spacecraft is exploring the red planet, sending back a flood of data and helping to unlock the secrets of Mars. When NASA's MAVEN orbiter arrived in 2014, it became the first mission dedicated to observing the Mars upper atmosphere. This region is the conduit for air to escape to space, a process that may have dried up early Mars. The most likely cause of this process is the solar wind, a stream of electrically charged particles blowing from the sun. When the solar wind reaches Mars, it interacts directly with the upper atmosphere, piling up ahead of the planet in a bow shock. Charged particles from the Mars upper atmosphere, seen here in colour, fill the pool of the electric field generated by the solar wind. These particles, or ions, can pick up sufficient energy from the electric field to escape into space. In this simulation, green particles represent medium energy ions swept back in the wake of the solar wind. High energy ions in yellow and red follow the electric field in a polar plume above Mars. Now, data from MAVEN are supporting this model of solar wind erosion. This graph shows the first ever measurements of oxygen ion flux around Mars, allowing us to see the solar wind driving the atmosphere into space in both the polar plume and the tail regions. As the MAVEN mission continues, new measurements will be key to understanding how these processes operate, shaping the ongoing evolution of the Martian climate.